Hello everybody, in this short lesson I'd like to talk about the domino effect, and here's the result that you can see. The effect is quite simple, and the majority of work is just uh, to be able to set up. So let's actually see how it was done. So here I'm starting with a basic box with some measures and just adding some details. Okay, then I'm cutting it into half and adding some normals, and then I'm deleting it, just keeping only the top polygon. Then I'm using a simple expression, uh, get box center expression, to add a point and in the center of my domino piece. Next, I'm actually creating the points that will represent all those numbers uh, on the domino shape. So here's the first point, and it has a PTID attribute of 0. The second is 2. If I just activate the point representation, and here's a attribute PTID 1. Then there is 3. We have uh, a PTID attribute ID attribute of 2. Then we have 4. Next we have 3, 5, 5, and we have 6. And all of this point has the attribute PTID, which we will use next. Okay, here I'm merging all the points and deleting its geometry but keeping the points, and I'm adding a p-scale attribute. So here's a sphere that I copied onto the points. Then I'm promoting my PTID attribute u from a point to primitive, and then I'm assembling them, so I have only 22 packed fragments. Then I'm just mirroring all the geometry, and afterwards, using for each, I'm adding domino attribute, and I'm using the z value. So the positive z will have um, the um, the detail iteration, and the minus, the negative geometry, the negative z place geometry will have detail attribute +1. So this way I could then separate them. If you see, have 5 and 6 on the positive and the negative z values. Um, this way, um, I'm here I created a custom shape that I want to place my dominoes, and I'm copying this domino attribute onto these points, which I will use later. So here I have my final dominoes, and here I'm using a copy to point, which has also this domino attribute that we created here, and it uses this channel reference, this domino attribute as well. And if you let me just finish the whole setup. Here we have our domino piece and some UV unwrap and just set up, and then unboolean the center of a domino, and then so here's the final result. As you can see, all those numbers are placed randomly. There is some repetition that we see, but we can try to um, play with those values just to get what we want. Okay. I could use Boolean method, but just in terms of speed, I decided simply merge all the geometry together without creating very complex geometry instead. And before copying all the geometry into curves, I did some manipulation of the normals. So so I could place them correctly. So here I'm using a polyframe which uses a normal as a driver, and then they were placed alongside of along the curve, and then I just used the normals and the cross product of normal and y vector to create a cross product of the normal. Okay, and here I have the geometry separated and all the numbers placed randomly. Okay, so then here also I'm creating a name attribute domino plus point number to use it later to assemble it in the for each loop. So here I'm promoting my name attribute onto primitives, which I use here, and I'm creating a back primitive of each domino. Okay. Next, in the .NET, here a simple RBD setup. So there's an object solver, a gravity, ground plane, merge all together, and the only thing that actually I added is the point group. Here I'm creating an active group, which allows me to use only fast particle. Here I'm saying if ID is equal to 0, then it's in group. And if you see, let me just a few frames, and we have active one piece of domino, and I'm doing a small expression of just effect at frame number 5, effect only active, and here's the force I've added. I could use some custom forces, but just as a simplicity of lesson, I'm using just according to direction. And this, in my case, it's x value, as you see, negative x value. So and if I play, as you see, I'm having a force just at frame number 5, and the rest is dynamics. Okay. Then I'm using unpack node, but here I'm before here I'm adding some colors onto my points and domino shape, just to be able to extract it later. Here I'm having some groups, and here I'm adding some custom colors onto the points and the shapes separately. Again, some normals. Here's the background. Okay, and the merge. And you can see we have our domino effect. Okay. Also, just to speed up my simulation, I scale my time to 2. And so here's the final simulation of our domino. So we can use our custom shapes just to tweak our direction, so we could place them correctly and add some forces and run with dynamics. We could also do it procedurally without any dynamics, but maybe we'll check it out in the next lessons with some complex setups. Well, um, well, this is all I'd like to share with you in this lesson. I hope it was useful and you like it. There will be more stuff, interesting stuff to come, and definitely subscribe. It helps me a lot and motivates me. Also, I'd like to thank my Boosty subscribers. Thank you for supporting me. It really helps me a lot. Thank you very much, and thank you for your attention. And I'll see you in the next lesson. Goodbye.